Hello, everybody. Thank you for joining us. I'm Kathy Wells, Editor-in-Chief of Equipment Today and OEM Off-Highway. Welcome to today's webinar, Optimizing Hose Cover Selection, Technical Fundamentals and Best Practices, presented by Andrew Smith, Devin Key, and OEM Off-Highway. Today's session is being recorded and will be available on demand this week at oemoffhighway.com. A couple of tips before we get started. Our presentation today will feature slides with live audio from our presenters. You'll note that your view within the system is customizable, so please feel free to adjust the layout and engage with different windows to meet your viewing preferences. You may submit questions for our presenters at any time during the presentation using the Q&A section on your screen, and we'll answer as many of those as possible. And last but not least, please be sure to check out the related content section for some additional information and resources there. Today's webinar is sponsored by Parker and will explore the engineering fundamentals behind hose cover materials, today's industry standards, and real-world application considerations. Parker is a Fortune 250 global leader in motion and control technologies. For more than a century, the company has been enabling engineering breakthroughs that lead to a better tomorrow. All right, today's presenters are Andrew Smith and Devin Key. Gentlemen, thank you both for being here with us today. At this time, I'd like to go ahead and hand over the controls to Devin to get things started with some introductions and then begin the presentation. Devin?
Or whatever they were called.
Hi, good afternoon, everyone. As mentioned, my name is Devin Key. I'm one of the product sales managers at Parker Hannifin's Hose Products Division, located up in Wickliffe, Ohio. So just a quick note of the agenda. We want to make sure that we touch on an overview of hose covers in general. We're going to go into selecting the right hose cover for your specific application, troubleshooting and replacement, some actual real-world case studies, and then also some of Parker's different hose cover options as well. So getting into the overview, really the purpose and kind of the importance of this, I really want to set the stage by communicating why the actual hydraulic hoses and the covers are really important. The hydraulic hoses, they're a pretty critical part of virtually every application in motion control. Everything from construction, mining, agriculture, and various types of manufacturing, they all rely on different hydraulic hoses to make sure that fluid can pass through each one of the different components for a platform. So first and foremost, we always want to make sure that we're putting safety front of mind. We want to make sure that everybody leaves work the way that they came in and that they get home to their families safe and sound. In this industry and these particular products, they can be dangerous despite sometimes being a little bit overlooked. The other thing is you'll make sure you can prevent some serious downtime by making sure that you're taking heed to the care and the condition of your different hose covers and hoses in general. You'll also see some cost savings. If you do prevent that downtime, you'll see significant cost savings there, but it's also a few other areas that cost savings can arise from. We also want to make sure that there are some various industry standards and certain performance and reliability markers that we want to make sure that we're meeting. And last but not least, we want to make sure that we're being mindful of the environment and protecting that where we can. So on the screen, you guys will see that there are about 9 different common hose failure modes. These are what we see fairly common in the industry. They're all going to have different causes and effect, everything from flex fatigue, corrosion, improper installation, heat damage, even kinking. The top one on the list there you'll see is abrasion. That's arguably the most common one that we see on a day-to-day basis. The cause is really, as it sounds, it's friction against that surface, and typically where that wear spot or that abrasion spot shows itself, that's where you're going to see a typical leak. Another mindful one that we're going to mention a few times in the presentation is anything with a chemical attack. So that's just going to be caused by incompatible fluids or chemicals that are running through the actual hose itself that can result in either swelling or cracking that could, again, result into some type of hose failure, potentially even a burst. So the impact of those various different types of failures that you could potentially see. We've already touched on downtime, but that's just, where everything comes to a stop. Whenever folks can't actually perform the tasks that they are, there to do, that's going to result in downtime for the actual equipment. And it'll also reduce the equipment performance if you have any type of contaminants, even if it doesn't get to the level of specific downtime where the machine stops. If you have reduced performance, that's reduced productivity. And again, that can raise your different maintenance and repair costs. It could also cause damage to different components downstream. Again, we always want to make sure that we're being mindful of safety. Certain failure modes can result in pinhole leaks or anything of the sort that could really damage not only equipment, but the human body itself. So we want to make sure that we can prevent these things any way that we can, or at least stave them off as long as possible before you have to replace anything. So what are some different methods that you can take to actually extend that life of your hose? There are a few different options and avenues that we have available to us. First and foremost being different enhanced hose covers, which is not to be confused with different either abrasion resistant sleeves and wraps, or even spiral guards and armor. There is a slight distinction between the hose cover and the different sleeves and wraps and guarding that's available as well. You could also be mindful if there's any special temperature requirements, if any heat shields or insulation would be necessary that could help prolong the life of a hose. And also making sure that that hose itself is being routed and installed and secured properly to minimize any adverse effects to the particular hose. And then last but not least, making sure that we're taking preventative measures by doing regular inspections and maintenance on the particular products.
All right, so now we're going to dive into selecting the right hose cover. Starting off, just kind of going over the difference between what a hose cover is versus an external sleeve or guard. So the hose cover is actually adhered to the hose in the manufacturing process. It cannot be removed. It's part of the hose itself. Sleeve is going to be the external protector or a guard that's going to be added after the manufacturing process before it's installed on a piece of equipment. So just kind of differentiating between the two there. So what are hose covers and why are they there? Hose covers serve as a barrier, so they protect the hose from abrasion, cuts, UV, chemical exposure, just general wear and weathering. What they're made from, most of the time we're going to see rubber. That's the most common one, but thermoplastics, textiles, and even metal, depending on your application. So metal would be there for high heat applications. They're mainly there to extend the hose life. So they protect the inner hose, the inner tube, and the reinforcement layers from chemical attack, abrasion, cuts, anything like we mentioned above. They're there just to generally enhance safety and performance of your system. So how do you go about selecting the hose cover? So the proper hose cover for your application will vary. There's a lot of different resources out there. So manufacturer catalogs is pretty much one of the main ones to go after. There are a plethora of information in there, technical data sheets. There's industry standards that we alluded to. We're going to go a little bit more into those a little bit later. Those kind of guide the performance and construction of hydraulic hoses. Material compatibility charts. So we talked about chemical attacks on the last slide. Making sure that your hose is properly selected and compatible with whatever chemicals might be flowing through it or surrounding it. You can always consult with technical experts like Devin or myself or any other manufacturer rep. We'll also publish case studies and application notes. We'll go over a couple of those later. And then any field testing or prototyping you guys might need. Types of hose covers. So we talked about smooth rubber being the most common. That's going to cover majority of your applications. There also come polyurethane, thermoplastic, fabric braided, heat resistant, wire reinforced covers, and neoprene. Basically just selecting the right cover for whatever the application is, whether you're looking for abrasion resistance, chemical resistance, heat resistance. That's kind of what would drive your hose cover selection.
So when talking about some of the different materials to consider when you're selecting your hoses. As Drew mentioned, there are 4 kind of pillars for these different materials. We represent the hose products division for Parker, so our primary product is rubber. So the more commonly referred to terms are going to be either neoprene, nitrile, EPDM, silicone. Those are all different rubber compounds that can contribute to the inner tube makeup. It's going to have different properties that are going to make it advantageous for specific applications. When you're using rubber, typically you're looking for something that's a little bit more flexible if you compare it to like a steel pipe or something that's like hard lined into an application. It's also going to have some really good chemical resistance and temperature tolerances. Thermoplastic, the compounds that typically make that up are going to be PVC or polyurethane. And these ones, they're a little bit more naturally abrasive resistant. They do have some UV resistance as well. And they're usually going to be seen in applications such as garden hose or air hoses, just things that rubber might get a little bit beat up on if it's used as the primary hose. Then you also have textile and or fabric covers. So whether it be polyester or Kevlar, fiberglass, that can be woven into the actual cover itself to make that up as opposed to extruding rubber. And again, usually that type of product is going to be utilized in some type of heat resistance and or cut resistant application. Anything where it's going to see some type of higher temperature or you need some type of level of fire resistance. And then if a textile or fabric cover just doesn't cut it and you have to get up to that, 450, 500 degree range, that's where the metallic covers are typically going to come into play. Usually you'll see some type of stainless steel braze or a wire mesh. And again, the ultra high temperatures, that's usually where that's going to be utilized. So each one of those, in addition to having the properties that are going to make it advantageous for certain applications, they're also going to have some certain drawbacks. There's going to be give and take with any different type of material that you select. So if you do go with a rubber option, while if you compare it to a hard line, it's going to be lighter than it. If you compare it to some of its other kind of hose options, it could be a little bit heavier. It's gonna likely degrade a little bit faster if it has prolonged and consistent UV exposure. And if it's just a standard rubber cover, it might have limited abrasion resistance when you compare it to some of the other options that are out in the market today. Thermoplastics, it is flexible, but it is less flexible than rubber when you do a kind of side-by-side comparison. Can be a little bit more brittle in the colder temperatures just because of the different compounds that are inside it and how they react to that different environment. And when you compare it to rubber, it does have a little bit more of a limited chemical resistance. Textile fibers, the setback there, it's generally going to have less chemical, like a smaller range of chemical resistance or chemical compatibility, excuse me. And it can fray over time depending on how it's stored and or being used. Now metallic, the big drawback there is going to be the weight, and it's less flexible, and it also is more susceptible to kinking, and it has the potential for corrosion if the particular metal is not a stainless steel that's being utilized. So some things to consider. Abrasion and cut resistance, is the hose going to rub? Is it going to potentially come in contact with anything sharp? Chemical compatibility, specifically when you're looking at a lot of different manufacturers, when you go into the back of the technical sections and catalogs, the chemical compatibility is going to be referring to the actual inner tube itself, but you still want to be mindful of the chemicals on the exterior of the hose, just in case that could have a potentially catastrophic effect on the actual hose itself. The temperature range of the product, be it the temperature of the media flowing through the hose itself or the ambient temperature surrounding it. Then also things like UV and ozone resistance, flexibility and weight, if there is any flame or heat resistance considerations, and again, any environmental or sustainability metrics that are trying to be met. So if you can't remember all of those things kind of off the top of your head, there is an acronym that's pretty standard across the industry known as STAMP. So this is really how we walk through and spec in different products. We want to make sure that with every application, we're asking all of these questions so that we're finding the correct product for the application that's going to be safe and perform at a high level and last as long as it possibly can in application. So what does STAMP stand for? It's the size, and that's going to specifically pertain to the inside diameter of each hose. That's how they're actually sized. So if you see a -8 or a ½ inch hose, that's going to be referring to the inside diameter of that hose, not the outside diameter. You also have the temperature. Again, you'll want to be mindful of the media flowing through it because depending on particular hoses, they could have different temperature ratings depending on what media is flowing through that particular hose. And you also want to be mindful of the ambient temperature. It's going to perform differently if it's in a controlled environment versus if it's out in the hot sun in the oil fields. Application, that's kind of the catch-all. That's where you want to ask as many questions as you can think of that's going to speak to how the actual hose is being used. Where is it going to be located on a particular platform? Do you need to consider any additional guarding because there's exposure at a particular point? Anything of the sort that can kind of fall under when, where, how, what the product is being used. Then you want to be mindful of the media as well. I would argue that second to abrasion, likely the most common failure mode that you'll see is some type of failure due to media incompatibility. So just making sure that what's running through the hose is actually compatible with the media itself, and that there's no splashing of any dangerous chemicals that could eat away at the outside cover as well. And then pressure, there's also a distinction here. Whenever you see the working pressure of a hose in a catalog, that's speaking to what the hose is actually designed to run at a consistent basis, which is not to be confused with the burst pressure, which speaks to more so the design factor of how that product can perform in the event of an emergency.
So we alluded to some industry standards for hoses, the most common ones being ISO and SAE. There's global specs or global standards and regional and local. So ISO is performance-based standard and specification, basically calling for what the hose has to perform at for each manufacturer's individual hoses. SAE is more of a construction spec, saying, hey, this is how the hose has to be manufactured and made. EN standards that's a European standard. So if you're selling or designing anything into Europe, just something to keep in mind and look up to make sure you're staying within their certifications and standards. Other standards, there's a long list, but an example of that would be UL 94, the flame resistance standard. So just making sure that you're selecting the proper hose for your application based on whatever industry standard or regional or local standard that you need to be mindful of. Testing and certification. So manufacturers we run a variety of testing and certification to make sure that we adhere to these global and regional and local standards and certifications and specs. The main one, abrasion resistance, that is a test that we do to qualify volume loss over a set number of cycles or to hose failure, flame resistance, and heat aging. So heat does not do well to specifically can cause the hose cover to crack and become brittle. So it's just something that we and many other manufacturers will test for. Chemical resistance, same idea. Chemical attacks can degrade the inner tube as well as the cover. So if it becomes brittle and will crack, it can lead to hose failure. UV and ozone. Carbon black is typically used in rubber hoses. So it's not necessarily something that everyone will test for because it has an inherent UV protection just due to it containing carbon black. But it is something that some people might test for. Pressure and burst rating, that is to make sure that the hose itself is tested under realistic conditions as it's hooked up to a piece of machinery, proper bend radius, making sure that it can adhere to its listed working pressures and burst pressure ratings. So impact of hose performance on your system design. So if you can kind of look at all the factors going into a system design and how the hose can influence it. So the fitting and end connections, that's going to determine your thread type. And then also the overall working pressure of your system is rated to the lowest rated component. So whether that's the hose, the fitting, it's just to be something to be mindful of. Flexibility and bend radius, basically ease of installation for your operators, as well as just maintaining safety on the assembly line. Weight of the hose, so a rubber hose is going to be more heavier than a thermoplastic hose, or a metal hose will probably be the heaviest of all of them. Just to consider that in your overall design. Thermal performance, just basically making sure you're selecting the right hose. We talked about heat aging and how heat is not good for hose covers. So making sure you have the proper hose composition in your cover to make sure it can handle the heat, and then make sure you're working as pressure and burst resistance. Make sure your working pressure and your burst pressures all fall within a safe factor for your system design. So some safety considerations to think about. So covers, they're there to protect the operators from hose failure and reduce chemical exposure. Flame resistance, it just preserves the hose's integrity when exposed to either open flames or heat sources in general. Static dissipation, proper grounding, it's just there to prevent static buildup in critical applications. So if someone's working on, say, a bucket truck and an electrical line, you don't want any arcing to happen. Ease of installation, we talked about that with the bend radius and the flexibility, just maintaining safety on the assembly line. Compliance with environmental and workplace safety regulations. We talked about the industry standards, just making sure that we're all aware of what standards we need to be implementing in our system designs, and then selecting the proper hose for that. And then integrating protective sleeves. This is basically when you can't design out a certain factor of your system design. You can always add sleeves and guards. So if you need additional heat protection or impact protection, or abrasion protection, you can always use a sleeve or some type of protection, either across the entire assembly or limited to a certain spot. Environmental and sustainability factors. So just in the manufacturing process, we're just always looking at new and eco-friendly ways to recycle cover material. It's just something that we're just trying to be mindful of, and most manufacturers are doing that as well. Yeah, just any new R&D of new hose cover designs, and limiting the amount of carbon or our carbon footprint in our manufacturing processes. So you can kind of think as across your total life cycle when you're designing a system. So you have your initial upfront cost, and downstream you have all the maintenance, installation costs, downtime, and then safety mitigation. So your upfront cost can kind of determine what you spend later in life. If you invest in a more robust hose on the front end, it can limit your installation costs, your maintenance requirements, and your downtime because of that, as well as increase your safety just due to it being a better hose for the application. If it's something you skip on the front end, you might increase your maintenance requirements, installation, and then later downtime, and it can become costly.
Okay, guys, I'm going to hop right back in to gather some insights from our audience. Not sure why I'm not showing up on camera here. There we go. We'll quickly share a poll to have you offer up some preferences. And while Parker does not currently produce these covers, we'd like to have you indicate what your interest might be for future development. So which of the options listed here would be most of interest to you? Would that be multi-layer covers, combining materials, for example, fabric over rubber to achieve multiple protective properties such as abrasion and heat resistance? Would it be smart covers, the integration of sensors for real-time monitoring of hose condition, such as pressure, temperature, and wear? Is it more eco-friendly and sustainable cover? The use of biodegradable, recyclable, or bio-based materials for hose covers? Or are you looking for halogen-free covers, covers that don't have halogens such as fluorine, chlorine? Or is it none of the above? Go ahead and cast your vote let us know what you might like to see next from Parker, and we'll leave this up for just a bit longer so you have a chance to consider these options. I see those votes coming in. Keep them coming. Let's get some more insights before we move forward here with our presentation. All right. That will do it. Thank you so much, everybody, for your participation here. And guys, I'll pass the controls back over to you.
Replacement and troubleshooting. So when do you actually replace a hose? What are you actually looking for as your kind of telltale signs to know that something needs to be taken out of service and replaced? So the first and most immediate one, if you actually see any exposed reinforcement, doesn't matter how minor it is, if you see the actual wire reinforcement or could be potentially textile reinforcement depending on the hose, if you see that coming through the actual cover, usually it'll have some type of visible crack, cuts, or it'll have an abrasion rub mark. That's going to be your first sign to know immediately that hose needs to be replaced. If it's not already leaking, it's a very high chance that it will start to leak. And again, pinhole leaks are the most common causes to injection injuries, and we want to make sure we avoid those at all costs. If there's any sign of blistering or softening or hardening of the cover, anything that kind of indicates a chemical change, that is going to indicate that there's some type of either chemical compatibility or a potential breach of the temperature range. You could also see, again, if you see any leaking, whether it be from the fitting or anywhere along the body of the hose itself, anywhere on the assembly, really, leaking is a telltale sign. Make sure you get that. Make sure you get that hose replaced. And then if you're seeing any severe discoloration or surface degradation, that can indicate that the material is actually breaking down. Typically, that's going to be from exposed UV and typically associated with some type of higher temperature in conjunction with that UV exposure. So again, kind of what can you do before you get to that step of having to replace particular hoses? You want to make sure that your entire crew is trained on the particulars of installing different hoses. In our particular 4400 catalogs, we have kind of a guide that has some of the most common mishaps when it comes to hose installation and how to correct those mishaps. Making sure that you're having some type of regular preventative maintenance schedule where you're inspecting the actual hoses before they go into use after they've been in service for a while. Again, just reiterating that the actual installation was correct and that torque, if there's any torque dimensions or specs that need to be adhered to, making sure that there's no twisting in the hose when you're doing the routing. And then if it's a really more of a harsh application, using any of the protective accessories that are at your disposal, evaluating that and seeing if that's something that needs to be utilized, before equipment goes into service.
So now we're just going to go over two case studies for real world applications. So this is a underground and mining application for roof bolting to make sure that they basically put in rods to make sure that the tunnel doesn't collapse on them. So the initial challenge with the customer, the hoses were failing too quickly just due to the debris flying around as they were tunneling away. They started off using sleeving and guards. It helped, but it increased the installation time on the hose itself and then the overall complexity of the hose assemblies when they're ordering. So what did we do with it, optimizing it? We recently launched a new critical protection hose cover that we're going to touch on here in a little bit, but we used Parker's CP hose to eliminate the need for those external guards. It's a standard option on all of the global core hoses, which are ISO standard hoses. So it eliminated any lead time concerns just because it is a standard product. It allowed them to get full life or full hose length protection and eliminate the need for the sleeving of the guards. The results, it ended up doubling the life of the hose assemblies. And it reduced the installation time because they didn't have to deal with any of the sleeving or guards. And then instead of having spot protection with those sleeving and guards, the CP hose cover runs along the entire length of the assembly. Another one that for OEM kitting, the customer was just looking to reduce the overall complexity for their facility as hoses were coming in. They were initially using SAE hose construction, which is not a single working pressure across all the hose sizes. As you move up in ID, the working pressure goes down. So -4 is greater than -16. So we ended up moving them over to Parker's Global Core, which is an ISO standard, which is a performance-driven standard. It's a single working pressure across all hose sizes. So one hose series can cover all 3,000 PSI applications, for example. One thing they were also doing was they were using sleeving and guards. So we replaced those specific hoses with the critical protection hose covers to give them full length protection. And then this one was a distributor of ours that was kitting them. So they had full assemblies ready to go, delivered to their assembly line. And that is something that Parker hose assembly plants, we can do this, as well as any certified Parker distributor in your area.
So Drew mentioned a few of them in the case studies, but we wanted to make sure that we go in detail about, pardon me, what some of Parker's hose cover options are on both the hydraulic and the thermoplastic side. So if you're looking at the screen now, where it shows a breakdown of the various options that you have available to you. One is missing, that will be our standard option, but these are what we would call our more enhanced options that you have for hose covers. The first three are pertaining more so to the rubber industry on the hydraulic side. And then we also have our Tough Jacket, which is actually a product out of our sister division, Parflex, and they specialize in thermoplastic hoses. So the Tough Cover hose, this is actually what I would consider our leading hose. It's what you will likely see most commonly in a lot of different applications that utilize Parker hose. When you compare it to our standard option, it actually is 80 times more abrasively resistant than our standard cover would be. And again, it has a wide range of different application uses. It is what's pretty standard in the market for the majority of our customers. But if you have a need that is a little bit more rugged and, you don't necessarily have the concerns with the different kind of bend radiuses, you also have the option of our Super Tough cover. So that's going to be 450 times more abrasively resistant than our standard cover would be. So again, if there is a situation where abrasion is a real concern and you're seeing high wear in particular areas, this would be a great option for it. It is a little bit less susceptible to impact, though, if you compare it to our Tough Cover option. Our third option is our most recently launched product. So this is the one that was featured in the first case study that Drew mentioned. It's our critical protection cover, hose cover, which is commonly referred to as a CP cover. So the big selling factor here is the fact that it maintains the abrasion resistance of the Super Tough cover. So it's going to be 450 times more abrasively resistant than our standard cover. But it also addresses the issue of impact resistance. As it currently stands, there's no industry standard that actually addresses and governs any regulations regarding to impact or foreign object kind of damage. So this was our answer to the market for that. It doesn't sacrifice any overall dimensions. Your inside diameter and your outside diameter, it's going to be the same. The bend radius, it also does not decrease increase. And you also maintain that same force to flex So, it's one of those products that is new to world, and it does not have a direct competitor on the market right now because, again, there's no industry standard that actually addresses impact. And we think that this is something that can certainly be utilized in a variety of different applications wherever hoses are being abused, for lack of a better term.
And then Tough Jacket. So this is our thermoplastic offering. We're just wanting to toss a little commercial in there for our ParFlex division. Basically, when we talked about not being able to design out certain things in a system, if you can't design out certain abrasions, Tough Jacket's going to be a really good application or a really good hose for your application, just given that it's 650 times more abrasion resistant or standard cover. So if this is something that ST isn't holding up to, maybe you can look into Tough Jacket and get a little bit better abrasion resistance without having to add on additional sleeving or guards or anything like that. If you're looking for more information, we have a lot of resources on Parker's website. So you can go to parker.com/hose covers to kind of get a kind of full breakdown of what we discussed here, as well as go into parker.com/globalcore. That'll go over our Global Core ISO hose offering, as well as dive into CP, critical protection hose, as well.
Okay,
I think
thanks, Drew.
we're
Thanks,
going to open it up
Devin.
to questions.
Tips for optimization of the selection of this pretty critical but sometimes overlooked component. And like Drew suggested, up next is our Q&A. We've got several questions to get to. So guys, we'll kick things off and let's dig in here first. Starting with, okay, so earlier in the presentation, you mentioned manufacturer catalogs and technical data sheets for referencing when selecting those the correct hose covers. Often it's difficult to navigate manufacturer websites. Where does Parker keep their data?
So catalogs and technical data sheets, if we go back to the previous slide, if you go to parker.com for hose products division, on the hose covers, the Global Core, they'll all be under resources at the top tab. There will be all of our technical data sheets and brochures for each hose series, as well as our 4400 catalog. That'll call out all of the technical information for each individual hose series. Or you can always reach out to us at hbd.support.parker.com, and we can get you taken care of.
Perfect. Thank you for that. And I apologize for my audio if it seems a little strange. I'll check with our technical folks on the back end, but I'm going to keep pushing forward with our next question. So this asker says, we've purchased Parker hoses that have come with a smooth cover and some that have come with a wrapped cover. Can you explain the difference between the two types and why you would want one over the other?
Yeah, so when it comes to the two different wrap styles you can see from Parker on some of our hydraulic hoses, that really just speaks to where they were manufactured in the world. We have a couple different manufacturing locations across the U.S., and they have different machinery at each one of them. Really, there's no difference in performance if you get a smooth or a wrapped cover. It's not going to be any degradation in the pressure ratings. It's not going to be any change in the bend radius, anything of the sort. It really just means it was made on a different machine, but the performance properties are going to maintain.
Awesome. Okay, let's move to our next question. You mentioned that the critical protection cover is slightly less flexible than the other covers, but is still manageable. I'm curious as to its routing abilities.
Yeah, so when you're routing the CP, it's going to maintain the same bend radius. So realistically, it should route the exact same as our tough cover would as well. And it also maintains the same force to flex. So there's no industry standard that actually regulates force to flex. That's just saying how much force you actually have to exert to route a particular hose. and we've been mindful to make sure that didn't increase. So you'll see the same routing capabilities for both the tough cover and the critical protection.
Wonderful. Okay, next question. Are there any operating conditions where you're more likely to have an interaction between the fluid in the hose and the outer cover? It seems to me that generally you shouldn't have significant contact between the fluid and the outer cover.
Yeah, I think we alluded to this when we were talking about like chemical attacks. So if he's talking about the interaction between the inner tube degrading, so you got to just make sure that the chemical or whatever media is flowing through your hose is compatible with that tube material, so it doesn't wear away and then cause an interaction with the cover. Ideally, in a perfect world, they would never meet. That's kind of the idea there. The other thing I can think of is heat. So we talked about heat. That can also degrade the cover or the inner tube and cause them to potentially interact and cause a hose failure. But just making sure that the tube material and the outer cover material are compatible with whatever media is flowing through or surrounding in the ambient area, then you should avoid that interaction.
All right, great. Serving up another question here. What is the best hose cover for coolant transfer applications where abrasion resistance is not that critical, but thermal conductivity is?
So just meaning that you need a conductive hose, if I'm understanding that correct? I don't know if we can get clarification on that question.
We'll see if we can hear back from our asker. Otherwise, we can move to another question and come back. That sounds good.
Mm-hmm.
Okay.
Okay, let's grab another one from our stack here. Which test method is used for testing abrasion resistance?
So I believe that's the Tabor test. It also depends on the standard certification that you're referring to, but I believe the main one would be the Tabor abrasion test, if I'm remembering correctly.
That's from the ISO 6945 standard.
Yes.
Okay, good deal. I haven't heard back from our asker on that one prior, so let's move to another question. When I first started in hydraulics about 30 years ago, Parker had a series of design bulletins they would give out. For example, Bulletin 0224-B1, Design Engineer's Handbook. Does Parker still have these bulletins available either in hard copy or online?
Yes, they are still digitally available on parker.com. Our suggestion would be to search by division just to kind of filter through some of the different literature that's available from our different divisions. But yes, that information is still available.
Okay, guys, I think that might do it for questions. Unless Devin, you want to try to field that question from earlier without any additional clarification?
Yeah, could you repeat that, please? Or could you repeat the question, please?
You got it. What is the best hose cover for coolant transfer applications where abrasion resistance is not that critical, but thermal conductivity is? Excuse me.
Oftentimes, EPDM covers are utilized in those types of applications. Without any further clarification, can't really dive too much deeper into that, but typically for those types of coolant applications, EPDM is going to be used.
We do have a couple more questions flying in, so I'm going to throw it out to you guys. Thanks for that, Devin. Is ambient temperature rating located in the 4400 catalog? It looks like the max temp ratings are for medium only.
That is correct. You would need to actually inquire with the division for the actual ambient temperatures, as we don't have them rated for each specific application. Typically speaking, our hoses are not going to be built to applications. They're going to be built to industry standards. So we can only put in the catalog kind of what pertains to those industry standards. And when you're talking about different ambient temperatures, that can be rather application specific depending on what's being used.
Great. Okay. So we have a little, we heard from our question asker. So just to revisit that one more time, for coolant applications where abrasion resistance is not critical, but thermal conductivity is, what would be the best hose cover option? And he said, specifically, if the coolant fluid is cold, we want to minimize heat loss through the hose.
Yeah, EPDM would still be the likely the best option.
Great. Okay, gang, that does it for questions, which brings our webinar to a close. I'd like to thank our awesome presenters, Devin and Drew, for their insights and expertise here today. Attendees, you'll be receiving an email from us soon with access to the playback and presentation, but please also feel free to visit oemoffhighway.com to check out more on this topic and other topics in our bank of educational webinars. Also, before you go, please check out the related content section for additional information and resources there. Thanks again to our speakers, and thank you all for taking the time to join us. This concludes today's program.